On Friday, you were supposed to watch the first 12 of these on the practice test video. If you didn't do that, well, I know this will come as a big shock. This is the test with different numbers. That's what the practice test is. So if you didn't watch 1 through 12, you better put that at the top of your priority list because the test is tomorrow. So make sure that you get to that. That's in the daily lesson videos to watch when absent. So that'll run you through the first 12 problems. Today we're going to finish up 13 through 21. And then you should have some time to work on the review assignment, which was also part of Fridays. Because you could watch the practice test 3-4 times before you take the test, and you're still not going to get the results that you want, because without practicing that, it doesn't get run through the gamut in your brain. And that's what it takes. You know, you have to run it past all your synapses for it to start saying, hey, I know how to do this now. So number 13 is where we start. And the directions, always a good thing to read, say simplify each expression, rationalize any denominators when needed, but this is kind of helpful. Assume that all variables are positive. So that means we don't have to do the absolute value thing. You know, that last step of absolute value, not a necessity for these problems. All right, so I'm looking at 13. And I think, wait a minute, isn't 64 divisible by 4? Sure it is. And there's x's on the top that could be simplified with the ones on the bottom. And there's y's that could be simplified. Well, they split that up, hoping I wouldn't notice that. I'm going to make it one big fraction. They do that. Test writers try to pull a fast one on you all the time. Now, 64 divided by 4. Let's see. Ooh, that's going to be 16. That's very, very nice number. Then, and we talked about this when we were doing these problems in 6-2. You can just think of this as canceling and cancel one x on the top and the bottom for that one. Or what's even better is thinking of according to the rules, the properties of exponents, which is when we divide, we're supposed to subtract the exponents. So 5 minus 1 is 4. And the reason I say that is because for the next one, you can't cancel. Look at this one. It's got a y to the negative fifth there. We can't cancel that. It has a negative exponent. So you have to know that when you have those similar bases of y, you have to subtract the exponents. 3 minus a negative 5 will become 3 plus 5 because it's minus a negative, and that'll give you an 8. Then we realize numbers behave differently than variables, so I'm going to split that square root of 16 out there by itself. And I have the square root of x to the 4th, which I can split up into the square root of x squared and the square root of x squared, so that I have those perfect square roots of something squareds. And then for my y's, I'm going to need 4 of those. Why do I need 4? Because 2 plus 2 plus 2 plus 2 is 8, and it has to get me back to what it was. So the square root of 16 is a 4. I'm going to have an x and an x, and then I'm going to have a y times a y times a y times a y. And then I'd simplify it. X times x is x squared. Y times y times y times y is y to the 4th. And some of you learned the shortcut that you could just divide. You could think of this little index as a 2, and 4 divided by 2 is 2. 8 divided by 2 is 4, and so you kind of skipped these 2 steps and went from here to here. Perfectly fine. But again, I've been teaching this for 25 years now, over 25 years now, and this way almost everybody in the class understands why it works the way that it does. So if you can skip those steps, skip them. Then the only other thing I would even bother thinking about would be absolute value bars, but they said don't do that. Assume that all variables are positive. So there it is. Let's look at 14. 14 typically is considered the toughest problem on the test by students. So my first question is, should we take a look at that one as one big fraction first? What do you think? There's some simplifying we can do there, isn't there? So let's look at it as one big fraction. The simplifying we can't do is 5/3. 5/3 isn't going to go anywhere. We don't have a number that'll divide into both of those evenly. And then for our variables, I'm going to go ahead and do subtraction, just so everybody remembers division is subtraction. So a to the 2 minus 3 is -1. b, 3 minus 1 is b squared. c, 3 minus 2, first power. Now, it's not simplified yet inside there because I still have a negative exponent. So I remember that as it sits right now, these have little ones underneath them. The only one that gets flipped, the only one we take the reciprocal of, is the one that has the negative exponent. The others stay right where they are. So the 5 is going to stay on top with a b squared and a c to the first. And then a to the first has to move downstairs with the 3. And that's so that we can make sure we only have positive exponents. All right. Is that problem done? No. All we did was simplify. There's an issue there. What's the issue? There is. We've got a root down there in the bottom. So at this point, this is when we say, all right, I don't have a choice. I got to split it back up. You know, I simplified it. I'm not done yet because I still have the cubed root of 5b squared c over the cubed root of 3a to the first. And that means I've got a cubed root, a radical, in the denominator. Okay, what do we know about that? Well, we know cubed roots can only be multiplied by other cubed roots. So whatever I multiply it by, it's going to have a little cube root on it. Has to. Does anybody remember how to get that out of there? What we have to do to make sure that our radical on the bottom is going to be gone? Anybody? It's been too long. We need to make the power match the index. Right now, that's a 3 to the first and an a to the first. We need this to be 3 to the third and a to the third, so that when we take the cubed root, it drops right out. That means I need a couple of more 3's and a couple more a's, but whatever I do to the bottom, I have to do to the top. Now, let's make sure our denominator is going to work. Cubed root of 3 to the third, a to the third. Okay, that worked out perfect. That's going to be 3a. In the numerator, we just have to follow the order of operations. So we're going to have to do 3 squared exponents before multiplying. 3 squared is 9. 9 times 5 is 45. Cubed root of 45. And we have an a squared, a b squared, and a c. Now, the only thing we'd have left to check would be, I wonder if I can break apart that cubed root of 45. Let's see. Third power, 45 would be right here. Well, you can't divide 45 by 27. And you can't divide it by 8 either. It is done. And when we did this section 6.2, I'm going to remind everybody that if you have done this correctly, most of the time you're not going to be able to do any simplifying when you get to this point. So it's just going to be the cubed root of 45 a squared b squared c over 3a. So really this problem was all about simplifying to start with, and then getting rid of your radical in the denominator. Like I said, most people view that as the toughest problem on the test. What do you think? You going to be okay with that tomorrow? Okay, because that's when you probably want to take a second look at and say to yourself, all right, how did we get that 3 squared piece again, that a squared piece? We already had one, needed 2 more. Now 15, after having wandered around while you did these last week, I would say most of you look at that and go, piece of cake, Cedarholm. I'm not going to have any trouble with that. So how do we do this multiplication in number 15? Aha! Now, if somebody does all of FOIL, am I going to count it wrong? No. If you do it right, no sweat. But my hope is that to save yourself a little time, you go, ooh, sum and difference. Hey, I can do fool. I don't have to do all of FOIL. First times first, and last times last. Well, 2 times 2 is 4. Square root of 3 times the square root of 3. Square root of 9. Can I get everybody to pay attention up here for just a second? Way too many people write the square root of 3 right here when they take this test. Don't be one of those people, okay? Do you see what they did? Square root of 3 times square root of 3 is square root of 3. No, square root of 9. Then we change it, and we keep rocking it out. Remember, that sum and difference pattern is supposed to give you a nice rational number. In this case, an integer. So it should work out perfect. Sum and difference. Alrighty. Please take a look at number 16. And don't write this down, but I want to show you what I see on this test every year. And that tells me people weren't paying any attention at all. We can't do that. That has addition in there. You can't distribute when there's addition or subtraction inside there. So help me out here. That 2 that we see for a power up there works only on the closest thing to its left. What is immediately to its left? Parentheses. We have to write it out twice. Can we do this one with fool, or do we have to do FOIL? Yeah, we do. This doesn't have that sum and difference pattern, so we need to do FOIL. So first times first, square root of 11 times square root of 11 is square root of 121. Outside times outside, 3 square roots of 11. Inside times inside, 3 square roots of 11. Last times last, plus 9. And now it's just simplifying and making it look a little prettier. What's the square root of 121? Yes, of course it is. And of course we notice we can add 3 square roots of 11 and 3 square roots of 11 because they have like radicals. If I stop there, am I getting full points? Every once in a while somebody does that, but not very often. So there it is, 20 plus 6 square roots of 11. It's not wrong to write 6 square roots of 11 plus 20, but most people will put the nasty little radical in the back there. So far, so good? Definitely easier than number 14, right? Yeah, less thinking. I mean, you guys were ripping through this last week when we did it. Well, this looks a little tougher. 1 over the square root of 2 plus 7. I should double check that I didn't skip any. Nope, I didn't. What's the issue with this one? Yeah. So we have to figure out what could we multiply by that would make it so there won't be a square root on the bottom anymore. test-taking strategy. Didn't we just do something where we multiplied a couple of square root thingies together and we got a nice number back? Yeah, the opposite. Fancy name, the conjugate. You know, it's the sum and difference pattern. So if that's the square root of 2 plus 7, we need the square root of 2 minus 7. And again, your focus is on the denominator. So go ahead and do your full on the bottom there. So far, so good? Now this one almost seems too easy for the numerator, doesn't it? I don't know that we had any of that easy when we did the homework. Now I absolutely will take that. Here's the reason I say that. When some of you get to college, you're going to have professors that say, this is not acceptable because we never leave the negative in the denominator. So what you would do instead is take the opposite of everything you see in the numerator. It's like you're taking this negative 1 down here and putting it up here. But like I said, you can stop there for me. That shows me that you know the big steps for all of this. I guess it's the accepted way that it's written in mathematics, is to always use the negative for the numerator. 18, that looks very different. So apparently they want me to multiply those, right? Because they're right next to each other. Can we multiply those together? They're both square roots. Yeah, we can do that. So let's see, 27 times 3, that's 81. Ooh, that's going to be a nice square root number. I like that. What's going to happen with those x's if I multiply them? X to the 10th, right. When you multiply similar bases, you add the exponents. Well, we've got a numerical part and we've got a variable part, so I'm going to separate that out. I really like that square root of 81. I know that's 9. And then again, realizing that some of you will do the shortcut of dividing. Nine x to the what? 5th. This one I couldn't help myself. I was thinking all the way through, this would be an absolute value bar problem, but they said assume all the variables are positive for this part of the test, so I don't have to put those on there. 9x to the 5th. Done. Ooh, that looks interesting. Square root of 192 plus 4 square roots of 27 minus 2 square roots of 3. I don't know about you guys, but I like things easy. I'd like to use the educated cheat on this one. Does one of those look like it's as simplified as it can possibly get? Which one? So then I think, well, the only way I'm going to be able to do this problem is if I can write square root of 27 as the square root of 3 times something. Oh, that's 9. And I'm not going to be able to do anything with the 192 unless 3 goes into it. Let's see, 192 divided by 3. All 3 will go in there 6 times. Ooh, that's a nice number too. Now, granted, you probably use a calculator to do all that splitting up business, but there it is. So now I need to know what's nice. Is the square root of 64 nice? What is it? 8. Square root of 3 something nice? Nope. Keep the ugly radical. You got to keep the 4. Don't forget that. That's another thing students forget. What's the square root of 9? 3. You already told me the square root of 3 is not beautiful. One more step before we can combine these. What is it? Now we're cooking with gas. Now we've got like radicals all over the place. So what would you get? Yep. Ta-da! So like I said, use the educated cheat. We know we can't put these together unless they all have a square root of 3 in them. Use that to your advantage. 20. People overthink this problem every year. Every year. 4th root of 7 over the 4th root of 2. So question for you. Do we have any nice 4th roots that we can simplify the 4th root of 7 with? The very smallest one we have is 2 times 2 times 2 times 2. That's 16. It's not going into 7. So pretty obviously the 4th root of 2 is not something we're going to be able to simplify. So what's the real issue with this problem? There is a 4th root in the denominator. Now, I know everybody wants to do something with that 4th root of 7 because you're like, that's ugly. We don't care. If it's on the top and it's ugly, big deal. If it's on the bottom and it's ugly, that's a problem. We know we're going to have to multiply by the 4th root of something. Don't overthink. How many 2's are up there right now? And that's why it was nasty. There's only one of them. How many do we need for it to come out nice? Yes. So how many more do we need? And what we do to the bottom, we have to do to the top. And now our denominator says the 4th root of 2 to the 4th, which is perfect because it's 2. And then we just do a little math following the order of operations on the top. 2 cubed is 8. 2 times 2 times 2. 8 times 7, 56. If we did this using the smallest numbers possible, we're not going to be able to do anything with the 4th root of 56, but just to double check. 4th root, 56 would be right here. The only possibility is 16. 16 doesn't divide into 56. So it's just going to be the 4th root of 56 over 2. And like I said, it's not pretty for the numerator, but we don't care. It's all about the denominator. No radical in the denominator. Please don't overthink that one on the test tomorrow. Think basic. Index matching powers. Index matching powers. That's a lot of gunk. Oh, but the dot thing says multiply. Okay. Well, 2 times 7, pretty obviously we're supposed to multiply those together. That's 14. 16 times 5, carry the 3, 80. Y to the, what do I do with those two? Yeah, so that's going to be y to the 12th. Better move my little scratch out of there. There. I've given myself a little bit more room. Alrighty, so I have 14. Oh, cubed root of 80. I think we can do something about that. I think we have a perfect cube that goes into that one. Yes, 8. 10 times. And then we'll take care of our little variables here. Knowing full well that some of you said, oh, 12 divided by 3 is 4. But just so everybody can see it. Well, let's go find anything pretty. Cube root of 8. We said we could pull that out. That better be pretty. What is a cube root of 8? It's 2. Got an ugly little cube root of 10 there. And then I've got what for my y's? So we will have 14 times 2 is 28, y to the 4th cubed roots of 10. Beautiful. So you'll get a brand new clean power chart when you get the test tomorrow as well, so that you can use that to figure out, how do I break all of these apart. But that is the back page of the test. And like I said, test with different numbers. That's what a practice test is in here. So I want you to take a second, kind of flip through and see if you would like me to come up with another example of any of the ones that we talked about today. So overall, you're feeling pretty good? All right, good. Well, then I guess I'll turn this off, because what you need to do, I better put this on there, is this Algebra 2 review, Chapter 6, Concept Byte, and 6.1 to 6.3. Now, my hope was that on Friday you did the front page, front and back, because this is really the 6.1, Concept Byte and 6.1 that I had covered in the video on Friday. So today you should really only have these back two to work on. But that's what you're going to do, and I'm going to wander around and see if anybody needs any help with any of that. And Google Meeters, always welcome to stay on, and if you get stuck on something, holler and let me know. Otherwise, you can sign off and then come back anytime before 11:40.